Hi, and welcome to the first section of this course, Getting Started with Python and Machine Learning. In this section, we will first get introduced to machine learning and some important concepts involved in it. Then we will step ahead to set up our system to begin coding implementations in Python. Now we move on to the first video of this section that deals with Introduction to Machine Learning. In this video, we will understand what machine learning is, along with its applications and the concepts related to it and widely used. Machine learning is a term coined around 1960, composed of two words, machine, corresponding to a computer, robot or other device, and learning, an activity or event patterns which humans are good at. The idea is that there are routine, boring tasks more suitable for computers and creative tasks more suitable for humans. According to this philosophy, machines are able to learn by following rules or algorithms designed by humans and do repetitive and logic tasks desired by a human. Machine learning does not involve the traditional type of programming that uses business rules. Some of the applications of machine learning that we are all familiar with are spam email filtering, online advertising, search engines, credit card fraud detection, disease diagnosis, presidential election prediction, instant speech translation, robo-advisor, and the list goes on. Now, let's have a very high-level overview of machine learning. So, machine learning mimicking human intelligence is a subfield of artificial intelligence, a field of computer science concerned with creating systems. Software engineering is another field in computer science. Generally, we can label Python programming as a type of software engineering. We usually build machine learning models based on statistics, probability theory, and linear algebra, then optimize the models using mathematical optimization. Depending on the nature of the learning data, machine learning tasks can be broadly classified into three categories as unsupervised learning, supervised learning, and reinforcement learning. So, unsupervised learning is when learning data contains only indicative signals without any description attached. It is up to us to find the structure of the data underneath, to discover hidden information, or to determine how to describe the data. This kind of learning data is called unlabeled data. Supervised learning. When learning data comes with description, targets or desired output besides indicative signals, the learning goal becomes to find a general rule that maps inputs to outputs. This kind of learning data is called labeled data. We can further subdivide supervised learning into regression and classification. Regression trains on and predicts a continuous valued response, for example, predicting house prices, while classification attempts to find the appropriate class label, such as analyzing positive or negative sentiment and predicting loan defaults. And the last one, reinforcement learning. It's when learning data provides feedback so that the system adapts to dynamic conditions in order to achieve a certain goal. The system evaluates its performance based on the feedback responses and reacts accordingly. The best-known instances include self-driving cars and chess master AlphaGo. In the context of supervised learning, we have a scenario similar to studying for an exam. We have a set of practice questions and the actual exams. We should be able to answer exam questions without knowing the answers for them. This is called generalization. We learn something from our practice questions, and hopefully, we're able to apply this knowledge to other similar questions. In machine learning, these practice questions are called training sets or training samples. They are where the models derive patterns from, and the actual exams are testing sets or testing samples. They are where the models are eventually applied, and how compatible they are is what it's all about. Sometimes between practice questions and actual exams, we have mock exams to assess how well we will do in actual ones and to aid revision. These mock exams are called validation sets or validation samples in machine learning. They help us verify how well the models will perform in a simulated setting, then we fine-tune the models accordingly in order to achieve greater hits. Now let's look into overfitting, underfitting, and the bias variance trade-off. The phenomenon of memorization can cause overfitting. We are over-extracting too much information from the training sets and making our model just work well with them, which is called low bias in machine learning. However, at the same time, it will not help us generalize with data and derive patterns from them. The model, as a result, will perform poorly on datasets that were not seen before. We call this situation high variance in machine learning. Overfitting occurs when we try to describe the learning rules based on a relatively small number of observations, instead of the underlying relationship. Overfitting also takes place when we make the model excessively complex so that it fits every training sample, such as memorizing the answers for all questions as mentioned previously. The opposite scenario is called underfitting. When a model is underfit, it does not perform well on the training sets, and will not do so on the testing sets, which means it fails to capture the underlying trend of the data. That's all for this video. Now that we are loaded with much conceptual talk, we will work with hands-on exercises to explore machine learning. In this video, we got introduced to machine learning and its concepts. In the next video, we will set up our system to work and code in Python.